This crazy GCSE question was sent to me by one of the Lung Gang on the Reddit page. If you guys want to submit your own questions, the Lung Gang Reddit page is linked in the description. It says, the diagram shows two circles with center O, 1, 2, and a regular pentagon, ABCDE. ABCDE are points on the larger circle. The pentagon has side length 8 centimeters. The diagram is shaded such that the shaded area is equal to the unshaded area. Work out the radius of the smaller circle. Give your answer to 3SF. All right. So to do something like this is just general exam technique. We focus on what's given to us. All right. What's given to us is it says that the shaded equals the unshaded. So in order to do this question, we're going to have to work out the shaded area and the unshaded area and equate them. All right. Okay, cool. So how are we going to work out the unshaded area? Well, the unshaded area is just the pentagon minus that circle. But we don't even know what the area of that circle is because we don't have its radius. And that's the point of the question. This is just general technique and advice to you guys. Whenever you see a question with circles and things on the vertices, or well, things on the circumference, draw lines from the center to all of those points. Okay, 1, 2, 1, 2, 3, 4, 5. I thought I couldn't count for a second. So, by splitting up the pentagon like this, we have 5 identical triangles, congruent triangles, okay? So, we can actually look at this problem from one of these chunks, basically, because 1, 2, 3, 4, 5 are all the same, right? So, let's just focus on one of these parts, okay? Now, what does that look like? We've got what? Let me draw it again for you guys. So we have that triangle, we have that segment, and we have that shaded bit there. So there's the shaded bit. We've got the arc. Okay, so this actually is to do with sectors and segments, okay? Let's fill out some data or information that we have from the question. So it did say that the pentagon has radius 8, not radius, side length. Side length 8. I'm pretty sure I read it properly. But yeah, the side length is 8, meaning 8, 8, 8, 8, 8. So on my diagram, this would be 8 centimeters. We don't know what the radius of this circle is, but I could call it R. Okay. What else is missing here? Well, we're missing the angle at the center, but we can easily work that out because we have split up a full circle into 5 separate parts. So you're doing 360 divided by 5, which is 72 degrees. All right. Now remember, I've written 72 there, but we're trying to work out this shaded area as well. Okay, so we have this shaded bit. Now we can work out that shaded bit, but what's missing now, there's so many things missing in this question. This is a tough GCSE question for sure. Is we don't know what the radius is of the big circle. Well, we can work it out. Let me just call it x. And we can do that using the cosine rule. You could split this in half and use SOHCAHTOA. It's up to you which one you want to use. So what does the cosine rule say? It says a squared is b squared plus c squared minus 2bc cos a. Here my a is 8. It's the one opposite the angle in question. So we have 8 squared is x squared plus x squared minus 2 bc. So when you multiply these together, you just get x squared again, cos of 72 degrees. Okay, so we've got 64 is 2x squared minus 2x squared cos 72. Now this is obviously going to give us some decimals. This is going to be like root 6s and root 2s and all that stuff. Cos of 72. I'm in radians, guys. Make sure you are in degrees. Oh, wait, no. Cos of 72 is just some horrible number times by 2. All right, that's not a nice number at all. Damn. 2 cos of 72. I was hoping that would be just a much nicer number. But anyway, there's ways you can rewrite cos of 72 as a nice number. So 2 cos of 72 is 0.618 ... x squared. I'm going to do 2 minus that number. 2 minus answer. So I get 64 is 1.3819 ... x squared. Now, I have that number in my calculator screen. Yeah, I'm going to do 64 divided by answer. 64 divided by answer. I get 46.3. X squared is 46.3 ... So x, we're going to root that answer, about 6.8052. All right. Now, I recommend you store this value. All right. Now, I don't know if you guys can. I'm going to try and. I don't think you guys can see that very well. Now, you guys can't see anything here. If I press. Nah, you guys can't see it. Basically, yeah, on my calculator, there is a store button. I'm going to press store A. All right. Also, in a previous video, I've shown you guys how to store values on your calculator. All right. I might overlay it so that later on, I'll have it on the screen here so you can see me storing that value. Okay. Because I want to use it for later. So instead of that, I'm going to call it A. All right. Now, how are we going to use that value? All right. Let's call it, actually, let me call it 6.8 so you guys can kind of see that better. All right. So with this 6.8, we can now work out the area of this shaded bit here. Okay. How do we do that? We do the area of the sector, this area of the sector, minus the triangle. Okay. Now, how do we work out the area of the sector? The sector is what fraction 72 is out of 360, which we already know is a fifth, right? And because we know it's a fifth, because we did it earlier, I can just write 1/5. So it's 1/5 times pi times the radius squared, which I stored as a squared. Now I'm going to minus the triangle. Now the area of a triangle is a half AB sine C. AB sine C. When I multiply these together, I'm going to say a squared sine of the angle 72. Okay, so typing that in my calculator. So I'm going to use alpha A to type that in really quickly. So we get 1/5 pi times a squared minus a half times a squared sine 72. 7.07. 58 ... I'm going to store this value as B. So I'm going to press store B for later use. So that's this section. All right. Then I'm going to add this section to be the shaded area. All right. So I'm going to add this to be the shaded bit. Now this shaded bit, yeah, that shaded bit there is it's doing the same thing, right? It's just this, but 1/5 pi r squared. Okay, so we're gonna add 1/5 pi r squared. So that is our shaded bit. The unshaded, so let's write this is our shaded. The unshaded, this bit is going to be the triangle minus this. Okay, so we're doing the triangle minus this bit. Okay, so my triangle is just this. So we're doing a half a squared sine 72 minus that 1/5 pi r squared. And they have said that these two values are equal to each other. Okay, so these two values are equal. So let's bring that down. Now this 7.0758, I'm just going to write it as B plus 1/5 pi r squared. So to do some manipulation here, we're going to take this over to that side to make it 2/5. Yeah, so that is moved there. And the B I'm going to subtract. So I'm going to subtract B to bring it over here. So I'm going to type that in. So I'm going to get 0.5 times a squared times sine of 72 minus what I stored for b gives me 14.9. So this bit here is 14.94. Then we're going to divide by the 2/5 pi. So I'm going to do that first, divide by 2/5, which is 37.36. Then I'm going to divide it by pi, which gives me 11.89. And then I'm going to root the answer. So I'm just going to write down the 11.89 ... is equal to r squared. So r is approximately 3.45 centimeters. Damn. That question's crazy. Are you sure it's 5 marks? Hey, yo, who sent me this? You might be wondering, well, you divided it by 5. But guys, if I times all this by 5, it won't make a difference, okay? So I only looked at 1/5 of the circle. But think about it. If this unshaded region, this shaded region equals this unshaded bit, that proportion is maintained when you look at 1/5 at it, 1/5 of it, right? So as long as I maintain that proportion everywhere, which I have, it makes no difference. But you get 3.45. Whoever sent this to me, they did not include the marks. In my opinion, this is probably worth a lot more than 5 marks. But what do you guys think? Would you have done it slightly differently? A very impressive GCSE question. But guys, if you learned something today, hit the like button, subscribe for more maths content like this. Head to the Lung Gang Reddit if you want to submit your own questions. And if you're interested in my GCSE courses, link is in the description as well. I'll see you guys in the next video. Nice.